An automatic transfer switch, or ATS, with a service disconnect function can be used as the main service disconnect for a dwelling. However, it is imperative that the ATS is specifically listed for use as a service disconnect according to the National Electrical Code, or NEC. Furthermore, the ATS must be rated to handle the maximum amperage of the electrical service, which in this case is 300 amps. The location of the meter pan relative to the ATS is also a crucial factor. If the meter pan is not located directly adjacent to the ATS, then a separate main disconnect must be installed to provide a means of isolating the meter from the ATS. This is important for safety and maintenance purposes. Now, regarding the generator's capacity, the question of whether a 45 kilowatt generator can adequately supply a home with a 300 amp service depends largely on the home's overall electrical load. A 300 amp service is typically capable of handling a peak load of up to 180 kilowatts. While a 45 kilowatt generator may be sufficient to power essential appliances and some lighting circuits during a power outage, it's unlikely to handle the entire load of the house simultaneously, especially if there are high-demand appliances such as air conditioners, electric water heaters, or heat pumps. Therefore, it's vital to carefully assess the specific electrical load requirements of the home. To ensure safe and reliable operation, several steps are recommended. Firstly, upgrade the electrical service to 300 amps if it isn't already. This provides sufficient capacity for both the generator and the home's electrical system under normal conditions. Secondly, install an ATS that is specifically listed for use as a service disconnect. This ATS will act as the main disconnect for the home, enabling a seamless transfer between the utility grid and the generator during power outages. Thirdly, if the meter pan is not adjacent to the ATS, make sure to install a separate main disconnect. This will allow for safe isolation of the meter from the ATS for maintenance or other purposes. Fourthly, carefully consider the specific electrical load of the home when determining the appropriate size of the generator. While a 45 kilowatt generator might be adequate for essential loads, a larger generator may be necessary for larger homes or those with numerous high-demand appliances. In summary, using an ATS as a service disconnect is permissible under the NEC provided it meets the listing and rating requirements. The generator's capacity must be carefully matched to the home's electrical load to ensure it can adequately power essential circuits during an outage. Always prioritize safety and adhere to all applicable electrical codes and regulations. When considering generator sizing, it is important to understand several key factors that influence the overall power demand of a home. The first thing is to create an electrical load calculation. This involves identifying all the electrical devices and appliances within the home, along with their respective power consumption in watts or kilowatts. Appliances can be categorized into essential and non-essential loads. Essential loads are those that are necessary for basic living and safety during a power outage. This typically includes lighting, refrigeration, heating or cooling systems, well pumps, and medical equipment. Non-essential loads are those that can be temporarily suspended during an outage without significantly impacting safety or comfort, such as electric stoves, clothes dryers, dishwashers, and entertainment systems. The next thing is to determine the starting wattage and running wattage. Many electrical appliances, especially those with motors, require a higher surge of power to start up than they do to continue running. This starting wattage is typically higher than the running wattage, which is the continuous power the appliance consumes while operating. Both starting and running wattages must be considered when calculating the total electrical load. Then comes the diversity factor, which is a factor that accounts for the fact that not all electrical devices will be operating at their maximum power consumption simultaneously. This allows for a more realistic estimation of the total power demand. Diversity factors vary depending on the type of building and the mix of electrical loads. Check with local and NEC guidelines. After this comes the total load calculation. Once all the individual loads have been identified and their starting and running wattages have been determined, the total electrical load can be calculated. This involves summing up all the running wattages and adding the largest starting wattage of any single appliance. This total load represents the maximum power demand that the generator must be able to supply. Here are some specific examples of common household appliances and their typical power consumption. A refrigerator typically consumes between 100 and 200 watts running, but may require a starting surge of up to 600 watts. A window air conditioner typically consumes between 500 and 1500 watts running, but may require a starting surge of up to 2200 watts. An electric water heater typically consumes between 3000 and 5000 watts running with no significant starting surge. An electric stove typically consumes between 1500 and 3000 watts per burner, with no significant starting surge. A lighting circuit typically consumes between 100 and 500 watts running depending on the number and type of light fixtures. A well pump typically consumes between 750 and 1500 watts running, but may require a starting surge of up to 3000 watts. Based on these examples, it's easy to see how the total electrical load of a home can quickly add up, especially when multiple high-demand appliances are operating simultaneously. In addition to considering the home's electrical load, it's also important to take into account the generator's capabilities. Generators are typically rated in terms of their continuous output power in kilowatts or kilovolt amperes. It's important to select a generator that has sufficient capacity to meet the total electrical load of the home, taking into account both running and starting wattages. It's also important to consider the generator's fuel type, runtime, and noise level. Generators are available in a variety of fuel types, including gasoline, propane, and natural gas. Each fuel type has its own advantages and disadvantages in terms of cost, availability, and storage. The generator's runtime is the amount of time it can operate continuously on a single tank of fuel. This is an important consideration for extended power outages. The generator's noise level is measured in decibels and can be a significant factor, especially if the generator is located near living areas. In addition to sizing the generator correctly, it's also important to install it properly. Generators should be installed in a well-ventilated area to prevent the buildup of carbon monoxide. They should also be connected to the home's electrical system through a transfer switch, which allows for safe and seamless switching between utility power and generator power. Transfer switches are available in both manual and automatic versions. Manual transfer switches require the user to manually switch between utility power and generator power, while automatic transfer switches automatically switch to generator power when utility power is lost. When using an automatic transfer switch, it's important to ensure that the switch is properly sized for the home's electrical service. The switch should be rated for the maximum amperage of the service and should be listed for use as a service disconnect. In addition to the transfer switch, it's also important to install a main disconnect switch if the meter pan is not adjacent to the automatic transfer switch. This will allow for safe isolation of the meter from the automatic transfer switch for maintenance or other purposes. In summary, sizing a generator for a home requires a careful assessment of the home's electrical load, the generator's capabilities, and the proper installation of the generator and transfer switch. By taking these factors into account, it's possible to select a generator that will provide reliable power during outages and ensure the safety of the home's electrical system. The National Electrical Code provides specific guidelines for sizing generators and transfer switches. It is important to consult the NEC to ensure compliance with all applicable codes and regulations. Also, it is important to have a qualified electrician perform all electrical work to ensure safety and compliance with local codes. The NEC addresses generator installations in Article 700 titled Emergency Systems, Article 701 titled Legally Required Standby Systems, and Article 702 titled Optional Standby Systems. These articles provide requirements for the installation, wiring, and operation of generators used for emergency, legally required standby, and optional standby power systems. Article 700 covers emergency systems, which are intended to supply power to essential loads such as fire pumps, emergency lighting, and communication systems during a power outage. These systems are typically required in hospitals, fire stations, and other critical facilities. Article 701 covers legally required standby systems, which are intended to supply power to loads that are essential for safety or health but are not considered emergency loads. These systems are typically required in nursing homes, assisted living facilities, and other similar facilities. Article 702 covers optional standby systems, which are intended to supply power to non-essential loads during a power outage. These systems are typically used in homes and businesses to provide backup power for appliances, lighting, and other convenience loads. The NEC also provides specific requirements for generator sizing in Section 220.3 titled General and Section 220.12 titled Show Windows and Track Lighting. These sections provide guidelines for calculating the total electrical load of a building and for determining the appropriate size of a generator to supply the load. Additionally, the NEC provides requirements for transfer switches in Article 700, Article 701, and Article 702. These articles specify the types of transfer switches that are permitted for use in emergency, legally required standby, and optional standby power systems. They also provide requirements for the installation, wiring, and operation of transfer switches. Some additional considerations for generator installations are proper ventilation, grounding, and overcurrent protection. Generators should be installed in a well-ventilated area to prevent the buildup of carbon monoxide. They should also be properly grounded to prevent electrical shock hazards. Overcurrent protection should be provided to protect the generator from overload and short-circuit conditions. Here is a summary of key considerations for generator and automatic transfer switch selection and installation. Properly sized generators and transfer switches are crucial for reliable backup power. Always consult with a qualified electrician to ensure compliance with the NEC and local codes. Safety should be the top priority when working with electrical systems. First, the load calculation should include all essential and non-essential loads. Secondly, consider both starting and running wattages of appliances. Thirdly, apply appropriate diversity factors to avoid oversizing the generator. Fourthly, select a generator with sufficient capacity for the calculated load. Fifthly, choose an automatic transfer switch listed for service entrance equipment if used as such. Sixthly, ensure proper grounding and overcurrent protection for the generator and transfer switch. Seventhly, provide adequate ventilation for the generator to prevent carbon monoxide buildup. Eighthly, adhere to all NEC and local codes for generator and transfer switch installations. Ninthly, have a qualified electrician perform all electrical work. Finally, regularly maintain the generator to ensure reliable operation.